Welcome everybody to our session on comparing Animator and Composer for creating animations. First of all, what's this presentation about? If you're expecting a cage fight between Animator and Composer, not going to happen.
But we're subject matter experts, or we think we are anyway. And so we're going to compare this very fairly.
So our goal here is not to tell you that you should use Animator or you should use Composer, but we want to make sure you understand the capabilities and limitations of both programs and what they can do and what they can't do. And that will allow you to make a better choice as to which program works best for you. Also, for those of you that may be sitting out on the sides, at some point the presentation will be different on both screens, as Callie uses one side for Composer and I use the other side for Animator.
So, who are we? I'm Callie, and I work for a reseller, Go Engineer. I was their 3D Via, soon to be SolidWorks Composer specialist for a couple of years, and I also do have my CSWP, so I do know SolidWorks as well. And this is my third presentation, so I'm very familiar with Composer.
And I'm Jim, I'm a CSWP. I've been using SolidWorks since the last century. I'm also a certified SolidWorks instructor, and I write the book Creating Animations with SolidWorks. And I've presented at SolidWorks World the last 2 years. Okay, so here's the question we're trying to answer. I need to make an animation of my SolidWorks model. Which should I use? 3D Via Composer, or SolidWorks Composer, or SolidWorks Animator? So the way we're going to approach this is to put that question in perspective. We're going to start with a different question. If you had to bet a year's salary on the outcome of this motorcycle race, which are you going to pick?
Well, will you pick one that has 450 cc's, one cylinder, 5 speeds, a seat height of 37 inches, or
a GT bike on the other side, 1,000 cc's, 180 horsepower, 6 speeds, low ride height? How many want to go with the motocross bike?
Ooh, they're
very
smart.
good.
They're quick.
That's the point.
Exactly. So it depends on the track. What are you trying to accomplish? So if you're on a dirt track, a motocross track, well, of course you're going to pick that bike.
And if you're on a paved track, the GT bike's going to do a whole lot better. So what's the point of all this? Which bike's going to win? It depends. You got to know more than it's just a motorcycle race between two bikes designed to race. And that takes us back to our original question. Some people think an animation is an animation is an animation. Not true. You need to know a lot more than that.
So, before you start anything, you need to know a couple of rules, ground rules. So, 3 things you need to keep in mind when you're creating a good animation. First of all, you want to use the tool that has the capabilities to accomplish what you're going for. You also need to know, what are you going for? What is your final result supposed to look like? And then you need to know how to use the software.
And knowing how to use the software is very important here, because we're going to show you the capabilities of the programs from the perspective of trained users. And key items here are both Animator and Composer are really easy to use. They're not rocket science. But if you're not trained, it really doesn't matter which program you use, because you're not going to get a very good result anyway. So training is key.
So let's talk about what are you going to do when you're thinking about an animation? What are your plans? So what is it going to be used for? How is it going to be viewed? Is it going to be interactive, or is it just going to play? What's your storyline? And what kind of motion are you animating?
And then there's other considerations here. Where are you in the design process? Are we going to start with something that's already built, or are we going to anticipate there's going to be changes to the models we're trying to animate? Do you personally do this all the time, or is this a one-time deal? What software do you own? What software do you know how to use? And you're going to do the entire project in Animator or Composer, or are we going to have to do some post-processing here?
Okay, so a little bit of background on both. So 3D Via Composer background. So what it's meant for is creating images for publications, also animations, obviously that's why you're here. Also for the web, whether it's instructions, assemblies, all of those types of things. Who would use it? Well, whoever is writing your manuals, marketing materials, etc. Basically, they say non-SolidWorks users. Well, kind of, because actually SolidWorks users are one of our top users of Composer as well.
For Animator, it's made to create animations of your SolidWorks models. And since we're going to be working inside of SolidWorks, we're going to leverage our knowledge of SolidWorks and leverage SolidWorks functionality, such as mates and cameras and appearances. Our target audience, you, the SolidWorks user.
There are training manuals available for both, so this is kind of what this one looks like. It is a classroom training available from your reseller. Also, 3dmojo.com is a good source, and YouTube.
On the Animator side, there is one book available. You can buy it here at SolidWorks World down at the SolidWorks store. You can go online and buy it from store.solidworks.com or through Amazon. There are tutorials available right inside of SolidWorks. And we should also highlight the SolidWorks Motion training course, because as we start talking about types of animations, when we talk physics-based animations, we can use SolidWorks Motion as the driver. And there's, of course, things on YouTube and some online training. Okay, we've broken the presentation down into a couple of sections, and the first part here is understanding what animations are, because you need to know that if you're going to pick a product to do it. Typically, when people ask the question, should I use Animator or should I use Composer? Well, they kind of lump both of them into the same category and think their capabilities are the same. But they're not. They kind of have this relationship. And if we break that down just a little bit further, it looks like this. Now, what are all those funny areas in there? Well, in the middle, there's an area where both programs will do the same job equally. Now, what do we mean by equally? It means you're going to essentially be able to do the same animation with about the same amount of work. To each side of that, there's an area where both programs can create the same animation, but one can do it better. Either it's got more tools or it's a whole lot easier. To the outside of that's another area where only one of the two programs can do what you need to do. And finally, there's that area outside in pink, and that's the area where neither program can do it, and you're going to have to go outside. So it's good to remember that diagram there, because you're going to see that again. Because you'll see it in all our section headers, and we're going to take the capabilities by those areas and work out from the middle.
Okay, so before we get started, let's all get on the same page. So just basics of an animation. What are you going to animate? Components. You're going to animate the viewpoint, how you're looking at your objects, your properties, effects. There's lots of different motion types available as well, different solution types, and each program kind of has strengths and weaknesses in all of those areas. So first of all, we have free motion and kinematic motion. We have a couple of examples here. So essentially in SolidWorks, they're mathematical bodies, right? So either they recognize one another or they don't. In this case, when we watch the animation, they don't know that they're solids. They just kind of pass through each other, right? Same thing over here with kinematic motion. It really is the same, but we have mates to tell them how to interact with one another.
And then we get into the physics side here for dynamic motion. In cases like this, we're going to use physics. So we're going to have quantities like gravity. We can have bodies contact one another and press on one another. So here we've got a little ball sorter. And gravity is going to drive all these balls down the ramps. So they have to roll on the ramp. They're able to bang into one another. And the sorter will then allow them to go out into different locations. The important thing is you notice that both results are different because there's no relationship from the starting position. You know, physics allows the balls to bang into one another like a pachinko machine, and where they come out is where they come out.
So let's talk about kind of comparing methods and motions between the two products. So physics-based versus non-physics-based. Obviously, SolidWorks has that capability. Composer actually does not. It does not recognize that it is a solid. It's for graphics only. As far as methods go, Composer can do everything that SolidWorks does with the exception of dynamics.
Let me get a section head. Where I did. Oh. Okay, so in this first part, we're going to look at things both programs can do equally. And the way...
Yeah, so we're going to go through, a customer has given us a task. We're going to create an animation. And of course, there's always going to be a change. They never know what they want right off the bat. So we're going to go through those changes. And we're going to show both in each program.
Okay, so the first task that Callie's going to do first is they want a simple all-at-once animation. What's an all-at-once animation? Well, it kind of looks like this. All the parts just blow up from the center at the same time. They go out, and then they come back. And they want a pause at the beginning, a pause at the end, and before the parts reverse in the middle, they want a pause in there.
All right, so here is 3D via Composer. How many of you have never seen this interface before? Okay, cool. That's good. That's exciting, actually. Get to learn something new today. So a little bit about the interface. It is keyframe based, so you're going to recognize a little bit of what's happening from SolidWorks. It's slightly different, but should still feel kind of familiar. Everything is recorded in a timeline. Unlike SolidWorks, we don't have a listing of all of the components in the animation timeline. Everything's going to kind of be piled on top of each other, and I'll explain how to deal with that. So, first thing we want to do is we're going to make it pause. We want to hold on to it for a second, and that's so that, you know, when you're starting an animation, when you hit play, you don't want it to already have started, so people think that they may possibly have missed something. So we're going to have it pause for a second and then start. So we basically just record that, hit a button, and record it. Now, moving forward, everything is going to be automatically recorded. So at whatever time frame, it doesn't matter what order you do this in, because all I'm going to do is move all of these out. And it doesn't know what order it happened in unless you move the time frame. So I'll grab all of these. So how many of you have used the SolidWorks animations and have done the exploded views and things like that? Okay, so this should look fairly similar. I mean, we're using a triad, right? We've got our XYZ axis. All of that is the same, so it should still feel a little comfortable. Almost there, almost there. Okay. All right. So from here, it all just goes out. All at one time. And then we can reverse that. Just hold down Control. It's going to pause a second, and we invert, and it'll go back together.
Okay, so when we go over to the SolidWorks side, everybody's familiar with SolidWorks. You may or may not see tabs at the bottom. In SolidWorks, all these tabs come under the View menu and Motion Manager. So if you don't see tabs at the bottom, just turn it on. Our interface is a little bit different here. If I create a new motion study, you can see in the motion study I've got all the components of the assembly listed. They each have a separate track within the timeline, and each component actually has subtracks to deal with motion, explodes, and appearances. So we have more visibility into the individual components. Now, one of the most significant differences between these two programs when we come to non-physics-based animations is in SolidWorks, mates are solved. In Composer, there are no mates. So that can be a blessing and a curse, depending on what it is you're doing. So if I want to do the explode on this assembly, the first thing I have to do is make sure all my mates are suppressed. Because if any mates are active, like these down here, things are not going to move. So I need to suppress mates, and that will allow me to come in here and move components. So now everything is just sitting wherever it used to be. When you make an animation, we can move the timeline ahead, and all the key points tell us is, at this key point, you be at this location. At this key point, you be at some other location. And then we allow the software to get it from A to B. So if I move my timeline ahead to 3 seconds, I can now take these 3 nuts and move them. And we do it the same way. I can select them either in the graphics area, or I can select them over here. And I can select them over there if I hit the right keys. And then we can move with triad. Okay. Same triad we saw in Composer. We can just drag all these parts out. As soon as I do that, I get new key points. So all the key points are saying nut, at time 0, you're supposed to be over there. At time 1, you're supposed to be over here. We could then go on and say, well, let's pick the 3 bolts. Same thing. Right click, move a triad. Easier without my glasses. Move them the other way. Take 1 link, do the same to the right. And you just gotta make sure you get the arrowhead. Get the other one, same thing. Move that out. Move this out the other way. And I won't do all the tedious stuff in later ones. I'm just going to take both of these together, move them with the triad. So the triad's kind of nice for us here. Okay, now what happens? If I tell it to play, they all move out. Okay, but I didn't handle that problem in the beginning. I said, well, we're going to pause for a second. Well, at the beginning of the animation, these were the key points where everything was. Well, this is a Windows-based program. I can just grab all those key points, and I can just drag them over to the right to 1 second. And now when I play it, it's going to start with a pause, and everybody moves out. Just like you saw in the animator, if I take all these key points, they're the ones that control the motion of all the parts. Hold down the control key and just drag them over to the right. Right click, because they're all still selected. I can reverse the path, tell the whole thing to play, and this will just bring them back together again. So both programs did the mechanics just about the same way, but the visibility is a little different in the timeline.
So next, our customer tells us that they'd like this to happen sequentially. They don't want it to all explode and collapse at the same time. We want piece by piece by piece. So we'll talk a little bit about how that will work.
Okay, since I'm still on SolidWorks here, the easiest thing is just get rid of the second half of the animation. So I'm just going to select all those key points and delete it. They all go away. Now there's a couple of ways to do this. One is I can just modify the existing animation. And since the first thing that we want to go out are the nuts, well, I just happen to have them all lined up in my feature manager here, so I can just take the ending key points and move them over to the left. So now instead of taking 2 seconds to get out there, they only take 1. Then I want the bolts to move. Well, there's 3 bolts, and they're the next 3 keys here. I just want them to start a little bit later, so I'll just drag them over to the right. Now, if you were to play that from the beginning, oops, yeah, it didn't move. It didn't do what I said. Why didn't it do that? Because I didn't tell it to recalculate. And you saw those yellow bars there? They were all left over from last time. A lot of people get in trouble because they forget to calculate. Next, we want the links to move out. I can grab all of this and just move it together and then shorten the time. I could then take the plunger and take all these other components and we'll just move them a little further down here. Oh, and by the way, these two are at the wrong time. Well, no problem. If I just right-click on one of them, say edit the key point time, I can tell it exactly where I want it to be. And now I've just pushed it back into position. This should play from the beginning. We get half of the animation. And it wasn't all, yeah, it didn't look. You know, working and talking at the same time is sometimes hard. Okay. I want to reverse it, same thing. Just hit the control key, drag it over, and reverse it. Okay. Now, one other thing we can do, since we're in SolidWorks, I can just start a new motion study here. If we already have an exploded view, I can leverage that. And the way I do that is with the animation wizard. We have choices to rotate, explode, and collapse. I can just tell it I want it to explode. And I have to have an exploded view first. Tell it I want it to start at time 1 and, oops, that's duration, sorry. 5-second duration. Tell it start at time 1, hit finish, and it dropped everything in the timeline. If you play it and it doesn't look exactly right, because notice both links went out at the same or at different times. I just find the links down here and we can just adjust key points to make them happen at the same time. Simple as that.
So in Composer, it's a little bit different. Absolutely, we can do the same thing, but we don't have all of the components listed out, like I said. So the way that we're going to work with this, first of all, I'm going to expand my time frame just by dragging that key out. I'm going to have it be 6 seconds long. So right now, as I said, everything's kind of stacked one on top of the other. In order to see one key at a time for that specific component, I have filters available. So basically what's going to happen is we want this to move first. So we'll select these, and I will filter my timeline so that only the keys that are affecting those components are showing. Now when I move it, that's all I'm moving, just what I've filtered for. So right now, I'm showing that at 0 seconds we have a keyframe, and at 6 seconds, well, I want that to get where it's going a lot faster. So I'm going to copy that key back to, whoop, not like that. I'm going to copy it back to 2 seconds. So it's going to start at 1 and move to 2. And then it's just going to kind of hang out over there until the rest of it happens. And we'll do the same thing with all of the components. So the next thing that's going to move out are the bolts. We'll filter for those as well. I'm going to have that not start moving until 2, and I want it to get where it's going by 3. We'll do the links. It needs to hang out until 3 and get where it's going by 4. Kind of see the process here. This one's going to start at 4, get there by 5. And these guys need to hang out there. Oop. Let's do this one too. There we go. So now we should have a step-by-step, just by adjusting the start and end points for each. Okay,
We go to the customer and the customer says, you know, that's really nice, but you got those nuts coming off and they really ought to rotate because they're threaded. So what we really like to see is when the nuts come off, they each rotate while the threads were engaged. And then when it comes back together again, we should also see them engage. So how are we going to do that?
All right, so let's take a look. Well, in Composer, the way that we do that is I'm just going to rotate this around, and I'm only going to show you one because it's a little tedious to do all three, but we can do complex motions for sure. We're going to start at 1 second, that's fine, and we can see here that it moves pretty quickly out. And it's already got the linear motion, we just need to add a rotation in there as well. So I'm going to come to about here, grab my item that I'm concerned with, and I'm going to choose rotate as my transformation option. And I get kind of a triad that looks similar to the one in SolidWorks actually. And I just choose the axis of rotation. Kind of a quick tip when you're using Composer when you're doing this, if you just click and release, you can kind of get a little bit more control over the angle of rotation. Over here on the left side in our properties, it's showing me that it's rotating positive or negative direction. And what's really great is you can type this in. So let's say we want it to rotate 270 degrees. When I hit enter, watch what happens on my timeline down here. It interpolates in between that. So it puts key points as it goes through, so you don't have to manually go through and say rotate a little bit, move, rotate a little bit, move. It just understands that that's what needs to happen. So from here to here, it actually rotates while it's, yep, there we go, while it's moving out. And you would just repeat that process with all three.
Okay, on the SolidWorks side, there's about 4 ways to do this. The first basic way is very similar to what Callie did, but she didn't mention one other thing that she can do, which I'll tell you in just a second, that makes the job a little bit easier. So I need to make sure this nut is not tied in here. And you notice, because I mentioned earlier, we got mates, so we want to make sure that this coincident mate is suppressed, because if it's not suppressed, this thing can't move. So what we would wind up doing is very much the same thing. We would come out to some point. Let me just turn this off for a second. We can move with triad, and using the triad, we can first of all drag the nut out a little bit, and then we can grab one of the rings on the triad. Find the ring, the blue ring here, and rotate it, and that will capture both the movement, linear movement and rotation movement. So this key point now says go from here to here and this at the same time. And I would repeat this operation over and over again, tediously. The problem being, when the solver goes in here, it always moves things the closest direction, like a lot of things in SolidWorks. So I can't tell it to move over here and rotate 360 degrees because that's the same as 0. In Composer, she's got the ability to tell it numbers greater than 360 degrees, and because it goes in and puts those intermediate key points in there, that's a plus. Okay? I have other ways though. I could have put an angle mate on this nut and used that to rotate it. Or, as I said earlier, we've got mates. Well, one very handy mate for all this is the screw mate. If I put a screw mate between a nut, or the inside face of the nut and the inside face of the hole, all I have to do is drag the nut, so the solver's saying go from here to here, and at each step, the angle or the screw mate is trying to back the screw off. So when we play that, the nut is rotated by a mate. So all I had to do is tell the nut go from here to here, and the mate took care of the rotation for me. Pardon?
Are you using gear mate?
No, that's a screw mate. Yeah, screw mates, gear mates, couplers, they're all relational mates. It says, when you do this, you do that a certain amount the other way. Okay.
All right, so now the customer would like for after the sequential explode, they want the pieces to disappear so that it's a little bit cleaner looking. So it should look something like this when we're done. As the components come off, they kind of go away, and we're left with just the base plate.
Okay, so as we said in the beginning, when we animate things, what do we animate? Components, properties? Well, fading out a component's a property. So in this case, that's what we're going to do. This is the sequential explosion, and we can see the nuts go out there and then the bolts go out. But when the nuts get out to here, the next thing we want them to do is fade out. Okay? So a good thing to do, and this is just a tip if you're using Animator, here's my 3 nuts on their tracks. I select all of them, and then I would go up and this little button says to update the key. All I'm doing is making sure it's got all the properties fixed at that point. So then I can take the timeline out a little bit, take those 3 nuts, right-click on them, and tell SolidWorks to hide them. Okay. Now you notice I get these magenta color bars. The magenta color change bars tell us this is a physical property that's changing, or an appearance. The green ones are telling me I've got motion, so I'm getting even more feedback. So why do I have all this mess in the middle here? Well, because this says show, this says hide, the keys over here say show. So all I need to do is take these keys, and I can just copy these down to here someplace. Notice there's no change bar between them because nothing's changing. It says show, hide, hide again, so nothing changes, and then show. And now when I recalculate this, when the nuts go out, they'll fade out. I can do the same for all the other components, and most of them are already done.
In Composer, it's super simple to do this. So right now I've got all of them done except for the first set. And really all you have to do is select your components that you're interested in changing, and we have effects. So you can fade in, fade out, do lots of different things. But all that's happening is we're changing the opacity property. So if you take a look over on the left side over here, right now it's set to full opacity. When I do the effect of fade out, it just changes that to 0. It's literally that simple. And then the nice thing is, if I copy this all and I want to do the inverse, it recognizes that, and it also will invert the opacity property. It knows that that's what needs to happen.
Okay, so what's our next task here? Did that one. The next thing the customer says, you know, this is all nice, but I'm tired of looking at the model in the same position. I'd really like you to rotate it, and I don't want to just rotate it about the screen. I really want to rotate about some axis of the model, usually whatever is straight up. So in this case, we'll rotate the model or change our viewpoint.
All right, to do that in Composer, there's several different ways. We can either actually rotate the assembly. I don't like to do that because then my neutral property, which I'll talk a little bit more about that later, is changed, and I don't like that. So what I do is use the cameras. So I'm going to record the first one, and by default, notice that when I made changes up until now, it automatically records that change. Well, that does not happen with cameras on purpose, because you wouldn't want it to record every time you zoomed in and out or rotated something around. That would get a little messy. So I want to record my first one here just by clicking that button, and then I'm going to move through and do the same thing in order to rotate it around. And basically I'm going to kind of, we can do this at the end, so that it's not quite so messy. All right, so we can go into just our align your camera and then record the different positions throughout. Just move your timeline. And then back to the beginning. And it'll rotate around.
Okay, on the SolidWorks side, many of you know we've got a wizard. We could go in and do a rotate model. But the bad news about rotate model is it rotates about the screen. So if you tell it to rotate about the y-axis, it's going to rotate it about the y-axis of your screen, not the model. But that's not a problem. I can do this a different way. Now you notice there's one track in here called orientation and camera views. Since we can only show one view at a time, we only need one track. And you notice the symbol on here has got the little red no sign on it, because by default we don't record the viewpoints unless we want to. I could turn that off and have it automatically record viewpoints, but I'm not going to. I'll do it manually. What we'd like to do is we're just going to take the key point from time 0, and I'm just going to copy that over for a second. So what did that do? It said, hold your position for the first second. Now what do I want it to do at 2 seconds? Okay, because it's going to take direct route from one viewpoint to another, I can't go beyond, 179.9 degrees, because if you get to 180, there's 2 solutions. So the easiest way is let's just rotate this 90 degrees at a time. How do I get a 90-degree rotation about the axis of the part? Well, this is something that Composer originally had and SolidWorks copied it. Remember our little reference triad over here? If I do an Alt-Shift and click the Y-axis, it's going to rotate 90 degrees. And then I can tell for orientation and camera view, record that key. Move out another second, Alt-Shift, record the key. They say, oh, that's pretty, that's a lot of work, but I said, what happens if I have to go around a couple of times? Well, it's not that bad, because right now I've got everything I need for a full rotation. So I could go in here and take all these keys and just copy them down further and play this all back, and it's just going to rotate. Now, the alternative to this is just using a camera. And the nice thing in SolidWorks is we can tie cameras to sketches, and there's a sketch sitting out here. I put a camera and just attach it to that circle and go to the camera view, and when I play this, we're going to look through the camera, and the camera's orbiting around our assembly while it's exploding. Okay, what's next?
All right. So the next thing that happens, as it always does, we've gotten through this whole animation process. We think we're doing great. And then a design change happens. Well, what are you going to do now?
I'm in SolidWorks. I don't care. Because in SolidWorks, I am using the model that's changing. If this link changes, and the dimension changes, it's just going to update. So right now it's 2.375. Let's just take it down to 2, not 3. And at this point, we'll just rebuild it. We'll rebuild it. Did it shorten? Where am I? Let's just check the link here and make sure I really edited the link correctly. Oh, come on. Link. Mouse problem. And link. And base extrude. There's the base extrude. Should have some dimensions on it here. Okay, this is the one time this has not done what I thought it was going to do. There we go. I can just take one of these dimensions here and I'm just going to shorten it a little bit. Do that. Control Q. Come on, part update for me. Show me how you do it in yours for a second while I solve this problem.
Live television, folks.
Yep.
So in Composer, it's not direct editing like that, because the purpose of Composer is to be able to create your communication documents, but we can push those changes from SolidWorks into Composer. So there's a couple of different ways you can do it. If you know that your entire assembly has a lot of changes that have been made, you can just come up to File and choose Update, and it'll update the whole thing. Now, if you know specifically one component has changed, just for the sake of time, you can do so right here and just choose Update. And again, just for time's sake, I have gone ahead and converted this into an SMG file, which is the Composer file type, but it could absolutely be a SolidWorks file. You don't have to convert it ahead of time. We'll just choose Update. It's letting me know that in the code, the file name is different. So do you really want to do that? Sure. So now I've got a lightning hole in there, and everywhere that that component was used previously, it's going to be just fine with the update. The animation's still going to work exactly the same.
It's the nice part about doing a two-person presentation. When you get stuck on something, you can pass the buck for a minute or two. In this case, the part is updated because once I rebuild the assembly and recalculate the animation, all the changes take place. So in this case, I have made a change to the part. In this case, I've shortened the part instead of just bringing the hole into it. But I don't have to do anything special to update it because it's just the SolidWorks assembly.
All right, so now we're going into the call-outs. So we need to know, what are these things called that are moving around? We need some clarity. And so each of us are going to show you how to add these call-outs in.
Okay, now this is one area that Composer was designed to do and SolidWorks wasn't, but it doesn't mean I can't do it. And the way we do it is something you probably already know, is you can put balloons on things. And that's all we've done here is added balloons to the individual components. And I don't have them on the nuts just yet, but you notice the balloons will move with the animation. So very simple. And if I had done this to the one where the parts fade out and play it, when the parts fade out, so did the balloons for the individual components. So it works very nicely there. But it's not one of those things they tell you about in SolidWorks, but it's not rocket science. Just turn it on, something you already know.
So the difference in Composer is that we have a lot more control. If you want it to fade in, fade out, you want the effects to change, the color, everything, it's designed for technical communication. So you have all of those capabilities. So essentially all I'm going to do here is select the items that I want to add the callouts to and do that. And I can change what shows up in the callouts. I can either have it be a bill of material ID, something that came in from SolidWorks, whatever it might be. Here we'll do the actor name. We can also change the shape of them. I mean, there's so many controls, and it's a technical communication tool, so it was designed to do that. You have a lot more choices. So they both do it very well, but there's a lot more choices in Composer.
Okay, the last task is, us having an animation on our computer isn't very beneficial. We really need to record it to something so that the customer can use it. And the process is very similar in both programs, and we'll let Callie go first and show you how she does it in Composer.
Well, basically I'm just going to file, save as, AVI, that's my choice. One thing that Composer is not, and it never pretended to be, is a photorealistic rendering engine. So that's what we're going to see a little bit with what Jim's going to do. There's a lot more choices as far as that goes, but this is basically just going to save it out. When we choose save, it's going to ask me to compress this using whichever compressor. Usually I just use Microsoft, but that's pretty much it.
Okay, now, one thing the customer threw in here at the last second, he said, I want it to be a certain length. Well, you didn't tell me that before, so how do I solve that problem? When we go to record an animation, it's basically a save button in the Motion Manager. So very similar to what Callie had to do over here. You only get two choices for the way you save it. You either save it as an AVI file, which is a type of video file, or you can save it out as individual images. The reason you could save as individual images, we tend to use that when we photorealistically render something, because if you do a video file, it's got to render each frame, and it keeps them all in memory until the end when it creates the video file. Hopefully you have a lot of RAM, because if you don't, you can lose it after hours of rendering. So most people that do these professionally just render them out as individual images, which are the individual frames. We go to third-party software, like $30 for QuickTime Pro, and it just puts them all into an MOV file, and we can play the animation that way. Some other control we have, we can actually control the aspect ratio, so it's in here. The frames per second. One thing that you have to be very careful of in Animator is there are two places that frame rate is controlled. All the time we were creating animations down here, there's a setting in the motion properties that we can set a frame rate, and that's telling the solver how often it's got to solve. When we take it out here to record it, this frame rate could be different. Now, I tend to record everything at 24 frames per second because that's the standard movie frame rate. And it's nice to get a standard because then if you do post-processing later, if everything's at the same frame rate, you don't have to have anything interpolated. And I think we can both tell it how much of the range. You don't have to record the whole range. If you then tell it to save, yeah, I don't care about that. Same thing, we're going to tell it what codec to use. One little tidbit is people think that codecs are in SolidWorks. No, the codecs are stored in Windows. What you're seeing for a list of codecs is what's loaded on this computer, just like you saw it over on Composer. She had a different list of codecs because that's what's loaded on her computer. One of those other fun facts is we see posts in the forum all the time that says, hey, I loaded this codec and it's not in the list. What'd SolidWorks do with it? Well, SolidWorks didn't do anything with it because it doesn't load it there, but we have a lot of 64-bit computers running around now. Codecs are either 64-bit or 32-bit. This is a 64-bit machine, you're only seeing the 64-bit codecs. When I play it back, all the players are 32-bit. So when you download codecs, you need to make sure you get both a 32 and a 64-bit because 64-bit SolidWorks can use a 64-bit to compress. Windows Media Player needs a 32-bit codec to decompress. Okay, now the other thing that's a little different here is he said, hey, this needs to be 15 seconds. Well, I could probably go back and move all these key points, but that'd be pretty tedious. So we have a kind of neat tool here. If I hold down the Alt key and I drag the top item over here to 15 seconds, it proportionally spaces everything. Okay. What's the other way I can do this? Playback speed. This isn't just the playback when I'm showing it here. If I have a 10-second animation and I want to make it 20 seconds, go to 0.5x and record it, and you'll get a 20-second animation. Just that simple. Okay, so that was all of our first tasks. We got everything in there? Okay.
I think so.
Okay.
All right, so moving forward, we're going to actually change it up a little bit. We're going to be a little bit less picks and clicks, and we're going to just do videos for you. So when we're talking about moving components, in Composer, your options are to use a free drag. I showed you using the triad linear translation, showed you some of those, and there's also several different specific explode modes.
Yeah, on the animator side, we're leveraging what we know in SolidWorks. We've got an exploded view, we've got the same move, rotate triad. If you're familiar with the triad, everything you saw me do was free drag. But if you right-click on the little ball in the middle, I can bring up a window and actually tell it to go very specific distances, very specific rotation amounts, so I can get very accurate that way. And we can move things by mates, and I also have a big category called motors. Is there a question back there, sir?
Once the animation is created, if you want to stop it or manually proceed with a click or a keystroke, that we can reduce the proportion of outputs made, or would we be able to do something with the animation to allow that?
I think there's two answers here. On this side, I have no way of doing that. In Composer, Callie will show you later. Yeah, go
I can do it.
Yep, she can do it.
Yeah, so yeah, they're in Composer, there are methods built in, and we're going to talk about that actually in just a few minutes. So it's built into the program, it's part of the functionality. All right, so a little bit of a summary here, moving components, Composer versus Animator. Lots of the same options. One of the things I did want to point out here is the exploded view. I didn't talk too much about this, but essentially what's happening in Composer is you're pulling a file in, obviously from SolidWorks. If there is an exploded view already created in SolidWorks, it will pull that into Composer. So you can reuse that. So we kind of put limited, because we can leverage it, but it's not exactly the same as what you can do in SolidWorks. But we still have most of the same other things. Obviously no mates, because it's a much lighter weight file on purpose.
When we talk about changing properties, some differences here. On the Composer side, things are done through a properties panel. And if you watch Callie work, there's a property panel in the lower left-hand corner. On the SolidWorks side, we control appearances. And that's the way we do it. For display types, on the animator side, I only really have 5 display types, and those are all the standard ones, you know, like shaded, shaded with edges, etc. She's got a lot of presets for technical documentation. It's just one click, it's there. Okay. I have display states, which is kind of a neat thing, and one of the areas of differences is she's got a thing called views, which captures a lot of different things together. Position, the appearance, transparency, etc. On my side, I can do kind of all the same things, but they're broken down by, I have saved views in SolidWorks, I've got display states, the properties. So similar, but just different in the way we're going to approach this. And photorealistic rendering, yeah, I can do it. Composer is getting better with each release, and they're getting there. So, you know, it depends on how photorealistic do you want it. Okay.
Yeah, the way I usually explain it is we can make it look really good, but it's not. You're not going to make anyone think that it was a photograph. So just in summary, when you're dealing with Composer, you've got filters in order to navigate through the timeline and talk about specific items. Also, we talked about selecting and editing the key points. We can update those, and most of the changes in Composer are done through the properties panel.
And on the animator side, you saw what our user interface was. You know, the timeline has got a lot more tracks to see it individually. That can be good at sometimes, bad at others. So I have to get into a lot more organization. Where you get a very long tree, I use a lot of folders to compress it down so I get the things I want, but I've got good granularity to get to the key points. I do have filters, which I didn't show you. Selecting and editing key points is still pretty much the same on both sides here. And updating is pretty much the same. You want to go first?
Oh, okay. So when you're changing the viewpoint in either product, we have several options. Either an automatic rotation. Actually, Composer can't do that. As I showed you, it's much more manual process. We can do the saved views, like Jim was saying. The saved views in Composer can hold a lot more information than just how you're looking at it. It's properties. It's a lot of information, actually. As far as interpolation path methods, well, Composer, it's pretty manual. Whatever you want to manually add in, you can do. So we kind of say there's really just one, whatever one you want to add in. But SolidWorks actually has 5 predetermined ones that you can use. And then Composer has this thing called the digger that's pretty awesome as far as viewpoints go. And I'm going to show you how to do that a little bit later.
When we deal with cameras to change our viewpoint, both programs, we really have no limits on how many cameras you can put in the animation, but you can only look through one of them at a time. Crossfade of cameras, in other words, when you change from one view to another, if you ever watch a movie, it just doesn't snap like that. One kind of fades out while the other comes in. Neither of us can do that. We have to go out to third parties to do that. Discrete positioning of cameras, in other words, that's key points. Camera be over here now, be over here 2 minutes later, and the camera just moves from one to the other. Attach a camera to a path. Okay, that's something I can do, which you saw in the one animation. I attached the camera to a circle. The alternative to this is something we can both do. Instead of attaching the camera to a path, we attach something else to the path and put the camera on whatever that object is. Think of it like you watch a Formula One race or an IRL race, you got a camera right over the driver's head. That car is the camera sled. It's taking the camera wherever it goes. The one other thing I have over here is when I move things, I can move them using equations. So I can make the camera path not uniform, but I need to speed it up, slow it down. I can use a set of data points for that, but that's leveraging functionality already inside SolidWorks.
All right, so now we're going to move on. That's kind of, we said we were going to talk about what we can both do fairly equally. Now we're going to move into what does Composer do a little bit better. Maybe they can both do it, but Composer's better or SolidWorks is better at doing it.
Okay, so I got the bullets on that side. I got the animations over here. We saw three kinds of motion in the beginning. Free motion, kinematics, and dynamic motion. As soon as you get into kinematics, I can do it a whole lot easier. Why? Because mates are solved. Because in kinematic motion, you drive one component, it drives others through the mates. Composer can do it, but it's a little harder because in Composer you have to go reestablish the equivalent of mates within the part. So if I have an animation something like this, it's a nice little robot. There's 7 different motions I have to do in here, and I've got lots of different ways to do this. All these angular translations, I just put angle mates between them, and I tell the mate you need to be at 90 degrees at this point and 180 degrees at the next point, and it just moves the mate between them. I can use linear mates, say be at 10 inches at this point, be at 50 inches at this point, and it just drives the component from one to the next. Mentioned that in kinematics we take something like this animation. There's a lot of parts moving here. What did it take to make this animation? I put a motor on one of the rotating parts. I told the motor, you'd be stopped at the beginning. I want you to speed up to some value, hold that value through the end. Because all the mates are solved, all the parts move. All I then had to do was change a couple of viewpoints, change a little transparency here so you can watch the pistons moving back and forth, and it was just that hard. Some other things because of mates. Gear mates are very handy. This is a little Mobius gear train here. There's something like 9 or 10 gears in here. They all have gear mates from one to the next. All I did to drive it is put a motor on one of them. Maybe you want to get in and look at planetary systems. In this case, I've used a set of 3 motors to rotate different things or hold different components. So you can, in some cases the sun gear is held fixed, sometimes the sun gear is held fixed. Relatively easy to do. You can also get into some strange things, like this was a question on the SolidWorks forum one day. It says, I want to run a round gear around a rectangular path. Okay, challenge accepted. That wasn't that hard. All that's happening here is this inner gear is just running around a path. Can't use a gear mate though. There is no gear mate that will, because gear mates are ratio mates. So I have no good ratio to go against for that outside. So all I did is just put a rotary motor on this, made it rotate at the correct rotational velocity, and once you get the start position correct, it looks like it's mated all the way around. Some other things we do, something most people figure out, animate a belt. If you want to know how to do that, go back to the presentation last year called Smoke and Mirrors and the instructions for how to do this. Or if you're really interested in animations, go buy the book. There.
You might want to mention, the books are also available in the SolidWorks booth in the Partner Pavilion and store in the back. And they're on sale 60% off if I don't want to have to carry them home. So you're never going to find a cheaper price on the book, 60% off.
That's a good deal.
That is a good deal. What's the book called? Creating Animation with SolidWorks. That's right. I tried to convince them they need one of those little cute things that goes on the smartphone.
I was looking for the slide number that had the book showing.
It is
13. I gotta remember where I am. I gotta remember which one this one is to come back to. That's what the book looks like.
That's what it looks like. Say what, you bought it yesterday? Jim Water.
Okay. Guess who I work for?
There's a question of how much the book cost now.
Ah, boy. I don't know. I think it's something like 20.
Mental math.
The other day it was 54, and it was 40% off. So do the math.
Okay, so it's less than that. Okay, now here's another one. This is kind of interesting. You know, we've got a part that's changing size, but I'll talk about the changing size in the next section. But how do you drive this motion? This is a decreasing sine wave, right? Because it's damping. Well, you might think, well, this is a dynamic motion thing. I want to use physics. This wasn't done with physics. It's just a rotor. It's just a reciprocating motor driven by an equation. It says sine wave, and then you multiply that by a decreasing function, and you get a damped sine wave. So by having motors, I can do those things relatively easy. Another one like this. Okay, you could do this with mates. And if I asked Callie to do this one, she could go in there and figure out how to do this with key points and make all these things move. But we'd have to come back tomorrow to see what the result was, because it would take a long time to do. Over here, I can do this relatively quickly just by bringing up contact and actually allowing this pin to drive the Geneva gear. One of the more challenging animations, you want to do a chain. I will tell you right now, if you want to animate a chain, make sure you really want to animate a chain, because it takes a while. It's not really hard, but it is very tedious, because every one of these teeth has got to connect to every link has got to connect to the link on both sides. It's got to be held in plane, and it's got to be held to some path as it goes around. The mates are greatly over redundant. Yeah, so I mean, you know, how many degrees of freedom does a part have? You start with 6, and each mate takes off degrees of freedom, and if you count each mate and how many degrees of freedom it's removed, it's something like 12. So you've got redundant equations that have to be solved, but it will work. And let's see, the other thing that's a little different, and we didn't talk about it in the equal part, is when you change a part, the composer does that very well as long as the boundary of the part is the same in both cases, because remember, there are no mates. Its position is being recorded. So if the part gets bigger, the center is still in the same place, but it can't push the surrounding parts. In SolidWorks, we're solving the mates. So if that link gets longer or shorter, the mates push the adjacent parts, and the animation will update. And I think I hit all of them in here, didn't I? Mm-hmm. Okay.
Now, what's easier and better in Composer? So a lot of what is easier for me is large assemblies. So all of you are obviously your SolidWorks users. You get a really large assembly, you start adding in animations, you're rendering, and you have to kind of sit there sometimes, click and wait, because it's such a huge file. There's so much background in there. So in Composer, I can do things like this, no problem. Something like this in SolidWorks would probably take you a while to render. Even just saving this video would take a long time. But because we're working with a subset of information, we don't have to worry about that, okay? Because it's just the graphical content. Also, just dealing with a lot of components, doing an explode in SolidWorks of something that has a lot of tiny little components, sure it can do it, but it's going to take you a good amount of time. Whereas in Composer, because we have those specialized explode modes, we can do it very easily and quickly. So kind of an example here of a lot of just very small components, a large number of those as well. It is actually very, very simple in Composer. Kind of to that same note, the different methods. So you can do cylindrical and spherical explode modes rather than just linear. So SolidWorks will do the automatic spacing in a linear explode, but we can do just, in this case, so this is a oil and gas, it's a packer. I don't know if anyone is familiar with that industry, but so because it is a cylindrical part and it has so many patterned type of things, it's going to look a lot better to equally space it about a cylindrical or spherical pattern rather than just linear. So it makes it look a lot cleaner as well. And we talked a little bit about this, the call outs and things like that. So absolutely, in SolidWorks you can add a call out in, you can add the bill of materials, but in Composer the nice thing is that you can control when it shows up, what's happening, all the properties, fade in, fade out, all that kind of thing, and it can change throughout the animation, whereas in SolidWorks it's kind of there or it's not. And then one more. There's lots going on in this one. So this is a roller coaster, and the main focus of this little animation is the cameras. So we have lots of different options as far as how we're going to look at the cameras. SolidWorks can do it too. We have sleds and things like that. So this one, it starts out attached to the car on the roller coaster, and then in a second it'll switch so that it focuses on the car and it watches that no matter where it goes. And then the third one is a stationary camera that just is looking at the overall motion that's happening. So it just kind of follows an area. And like I said, SolidWorks can do it, but it's a little bit easier because it's built in as a specific function in Composer.
And the other big thing is the subset of information. SolidWorks, even if I load lightweight, I still got a lot of information in there. Okay, now the next to last section are things that can only be done by one program. So what we're going to show you here are, Callie's going to show you things she can do that I've got no hope of doing over on this side, and then I'll show you some things that she can't do in Composer, and you compare those.
And this is really where you start deciding what is the best product for you or the best method to attack something, because it's cool that things can, they both do that. Well, that really doesn't help you. The reason that you would use one over the other is because the other one isn't capable of it. So one of the first things that when we were creating this presentation, it's kind of cool that in Composer you have to kind of fake it, but you can do it. Titles and credits, so essentially you can have a note kind of come through and look like a credits, like a movie. SolidWorks can't do that. This one, the restore neutral, this is a big one for me when I'm creating animations. So when you bring the SolidWorks model in, the placement of those objects is its neutral position. And that's fine. SolidWorks, of course, has the same positioning, but it's very easy to put everything back where it started with one click of a button in Composer, and that is not there in SolidWorks. The digger is kind of like a detail view on steroids. That's generally how people describe it. So you can change what's showing up in the digger, not only just that it can fade in, fade out, have all this excitement going on. But also you can kind of, it's called the digger because you can dig into your assembly and you can see the internal components. You can kind of step through that so that it's less and less or more detail in there. And that's one of the really nice features that's developed specifically for Composer. When we're talking about things like training manuals, interactive content. So this is not just an AVI. You're not going to save it out as a file that just people watch. This is something you might host on a website or have available on a mobile, a laptop or something out in the field. So step-by-step instructions, you click next, you click next. It can be a picture, it can be a button, it can be the actual object itself. What's also kind of cool, and I don't have a video of it because I didn't really know how exciting that would be, but you can link it to external files, you can link it to another website, you can link it to, let's say maybe there's a specific documentation that you need people to see, you can link to that file and that kind of thing. So the interactive content is a big differentiator. Things like arrows, it may not seem like a big deal, but when you're dealing with technical communications, just being able to fade it in, have something specific, rotate to the right, you know, it seems very simple, but it is very important. And in SolidWorks, you can do it, I guess. You can kind of fake it in if you modeled an arrow, I guess. But here, it's specifically designed for that, and it's super easy to do. And then the last one is the storyboard. And this one, essentially what happens is, I talked about views earlier and how it records a lot of information in each of the views. They're basically like snapshots in time. It records colors, it records placement, it records whether the call-outs are on or off, it records backgrounds and camera views, it records everything. So the nice thing about that is we can, just like in a real a movie type of situation, you can create a storyboard, steps through, step by step what's happening, and you can drag and drop that onto the timeline to create your animation. It just helps you reuse all the information that you've already done, and you don't have to spend the extra hours or however long it would take to recreate stuff you've already done.
Okay. Having had to create arrows in SolidWorks and animate them, I can tell you that's a whole lot faster than what I had to do. Okay, things we can do in SolidWorks that we can't do in Composer. Because we're working in SolidWorks, I can change the shape of things, I can animate the parts themselves. So there are things like a spring. Notice the spring's not only going up and down, but its diameter is changing as a real spring would. If you missed that again. Okay. How about something like this? We're going to bring a piece of tubing onto a bender. It's going to clamp in the bender, and we're going to bend the pipe as we drag it around the mandrel. Okay. I can do that because I'm basically using in-context features to manipulate things. You know, maybe you just need to do something simple like twist apart. Okay. Relatively easy. Maybe you just want to bend it. Okay. So, well, you saw a chain before. What's different about this chain? The last one was all key points. This is physics-based. If you watch the chain in here, you notice it's wobbling up and down. In this case, the chain is actually being pulled by one of the sprockets and pulling the other sprocket. And you know, if you think this is just a quick snapshot, you notice there's a point on one of the links going around here. That's why I also have embossing on some of the sprockets, so you can see that they're really going all the way around. This isn't just a little looping video. Some other things that sometimes challenging. I need a waving flag. Maybe I want to wave a SolidWorks flag. I can do those things. One we see in the forum a lot of times. How do you roll something from off one reel and onto another reel? Okay, we have techniques to do that. Is the cable really rolling off one and onto the other? No, but it sure looked like it was. but it's just a technique we can use inside. Some other interesting ones. Here's one Dave asked me to do a little while ago. We're actually animating a fillet. This is a multi-radius fillet with setback. So you can watch a setback moving here. You watch these setbacks move, and you're watching the geometry update. And, you know, there's a couple of tricks to doing this, but, you know, I can recreate this whole thing in a matter of a couple of minutes at this point. First time took a little longer. It was billable. 3 days. This is one I showed yesterday at the presentation in here. We're animating the box, and also notice that the annotations are also updating with the correct size as it's moving. So if anybody tells you you can't animate part features, they're not correct. Not directly, you can't do it. How about some things like this? Okay, now this is a physics-based solution. I actually use SolidWorks Motion to do this. Within SolidWorks, without SolidWorks Motion, there is a physics-based solver called Basic Motion. Can't quite do this. The problem with Basic Motion is there's no coefficient of restitution, so things can't bounce. The ball would just hit the plane and roll down it. Okay. How about a dynamic section view? We'd like to go in here and, you know, you'll see this hand punch again in a couple of minutes, but, you know, it opens and closes, and then we actually cut a dynamic section view and look at it. And we only cut some of the parts. You notice you're not, the die and the punch are still not sectioned. Here's one that doesn't look like much. If you watch this box, you notice the background's changing, and if you look at the sides of this box, they're actually coming in. There's an effect in photography called the Hitchcock effect, and you've probably all seen it and just didn't know that's what it's called. It's where a camera can either move forward or towards an object while it's changing the focal length of the camera. So perspective changes and the background changes. You say, well, you know, but you notice this line is always exactly the same length. The problem here is this is not a linear problem. Changing the focal length is just, you know, changing an angle from one to the other, and that can be linear. But the distance the camera has to be follows an inverse square law. So I can do that here just because I have equations that I can drive the camera. So it starts moving in very fast, and it's got to slow down based on inverse square law to keep that edge the same. We mentioned interpolation modes earlier. In this case, all these blocks are told to be on the left end at time 0 and the right end at time 10, but they're all interpolated differently. You know, the default is linear. It says at time 0, you go to whatever speed is necessary instantaneously, and you hold that till you slam into the wall at the other end. But we can tell it to start slow, pick up speed, and slow down at the end. Or we can tell it like the one on top. You hold your position right there and get in the transporter and go down to the other end at the end of the animation. And finally this one. You know, this would be a little hard to do with key points. But, you know, we're using gravity, we're using contact, and this was done in Basic Motion because you can see one thing that doesn't happen. You notice the ball never bounces. It always hits the surface. That's one way you can tell it was Basic Motion. Okay, so there's a couple of differences in the way we do. We mentioned earlier we can photorealistically render things, and that's what you're seeing here in this animation. But there's another little trick going on in here. You know, the saw's cutting the wood. Yeah, well, it's like the smoke this morning with the barbecue. And you notice the wood falls away. Or the other interesting one in here, and this is an old one. Little pencil sharpener. Pencil sharpener was created like in 1998 by one of the SolidWorks employees. Got motors so we can go in here and make the gears turn. We go over this end, put the pencil in it, and sharpen the pencil, and then pull the pencil out and look at it. Because we're able to leverage the abilities of SolidWorks to do in-context modeling.
And then at the end of the day, there's still some things that neither one of us can do. So we're going to kind of cover those. You're going to have to use a little bit of post-processing in order to get some effects that you may want.
I'll show you one here, and then Callie will play the other one in a second, and I'll show you how to build that one here since we have just enough time to do that. You saw this morning they're going to have solar studies. Well, this is one done 2 years ago. I can't in SolidWorks play 5 video clips at once, and that's what you're looking at there. I made all the 5 video clips together, but to play them at the same time, in this case I used Adobe Premiere. And the other thing I needed Premiere to do is, clock is a round face, but the frame that it comes out of is rectangular. But you're all aware of green screening. You see it on the news every night, so that's how I got through the last one. Now, the things we can't do in both, we can't combine clips within SolidWorks or Composer. So when we need to do something like this animation here, this was created as 4 clips that had to be put together. There's also transition effects. When we go from one clip to the other, we're going to fade one and bring the other one in on top of it. Maybe you want to put some sound in it too. Now, years ago, this was a little bit harder. It used to cost you some serious money to get a video editor. There's free video editors now. Microsoft has one. It's called Live Movie Maker. Kind of looks like this. Really tough interface. You look at the screen, it says, click here to browse for videos or photos. Okay, I can do that. There are my 4 clips. So I'll just select all of them and say open. Drops them on what looks like a cross between the storyboard Callie showed you and a timeline. And as a matter of fact, there's a little current time indicator or timeline here. If you watch the preview, you can watch it go through all the clips just to make sure they're in the right order. If they're not in the right order, it's just drag and drop to get them in the right order. Might like to put some titles in here. So there's a button called titles. And, we'll call this the hand, I guess caps lock is on, isn't it? Hand punch. And delete all the other stuff. We've got basic tools in here. If we want to change the color of this, we want to make the font bigger, we want to change the font, position it around the screen. A lot of presets in here, so maybe I want to have this look a little different here, so when this plays, you can see the preview. Very easily done. Go to the end of the clip. We want to put some credits in here. So this is SolidWorks 2013. So there's a credit at the end. Credits, they scroll. Does that automatically for me. What else do we need? We need some animations or some annotations in here, because in here I'm going to do a section view. So I ought to go into this point and say I need a caption. So we'll call this section view. And probably white isn't going to be good. I want to make it dark, so I can just put that up in the corner, and it's another item on the line. I want to do a crossfade. Go in here, and there's a whole bunch of visual effects. It's not it works if this is in the center better. I want to do effect view. Why am I having trouble finding it? There it is. Okay, so find a crossfade in here. You see these are all just pre-canned, and I can apply it to all at the same time. And what else do I want to do? Maybe we ought to put a little music on this so we can tell it to add music. Go find a little music to put in here. We can preview this. What is my music going to do? So how long did that take? I would clean it up just a little bit with a few more annotations and stuff, but in a matter of 2 or 3 minutes, I'm able to take the output of either of these programs and put it into something else. Okay, so we got all that, and I could save it out, of course. And what's left here? Oh yeah, let me just go back to, I'm going to kick out of the slideshow. Okay.
So basically, which one do you use? Which one's better? Well, it depends on what you're trying to do. Which program? It just depends.
So, in quick summary, if you're going to pick one of these programs, you got to recognize each program's got advantages and disadvantages. Some are easier in one, some are easier in the other. Some are only done in one, so you have to understand the purpose of the two programs and how that's going to affect you. It's more than just the picks and clicks. You got to know how that animation is going to be used. How are you going to view it? Is this going on a little handheld device? Is it going to be in a room like this? Is it going to be in the shop on a monitor where a person's going to have to click through it? What type of motion you're using? And there's many other requirements your customer gives you that's going to have to control the design intent of the animation, which in turn determines which program you're going to use. Above all else, if you don't know the software, you're not going to create a very good animation. So do some training, whichever program you use.
That's all, folks.
Okay? Any questions? Not really, because in all the video programs, and the thing is, both of us use different file types in these presentations. We make an AVI file, but what are video files anyway? They're a way of storing a whole bunch of individual frames. The file has got to record whatever the aspect ratio was, and it's got to have a way to play back the frames in order. They all do that. Where you get into the differences is in the compressors, and in a lot of cases we would record them here. We always record AVI, that's all we can do. That Windows Movie Maker records WMV files, but we'll compress them, and like Callie said, she'll use the Microsoft Video 1, I use some of the other codecs, but in the end we would take a different program and convert them over to MP4. And I use a thing called Handbrake, which is free, just to convert them. And that really reduces the file size. But remember, since you're recording frames, the size of the frame matters, because it's got to know what each pixel looks like. Anybody else?
On your explosion, early on in the process there, you talked about turning off the mates.
Yes.
You do the explosion and wizard, you don't necessarily.
That's correct. And you notice one different. Over here, I have change bars between the key points. In Composer, you just have the key points. Those change bars are different colors depending on what they are. When I use the animation wizard, they were orange bars, which say, I'm ignoring the mates. I'm just going from here to there. Okay. Yeah.
I had trouble with combinations of figuring out the window size, the wall, and like I say, you're going to get a bad output.
Mm-hmm. Yep. Yeah, the thing is, part of that, you usually get that with the Microsoft Video 1 codec, and I've talked to the developer about that, and he said, sometimes it'll work, sometimes it won't. They put the warning in the code just because it's usually an aspect ratio thing where if you use one aspect ratio, it'll work fine. If you use another one, it won't. I rarely use Microsoft Video 1 because if you see a video that's kind of banded, it's probably been done in Microsoft Video 1 because it's only a 256 color codec. So if you had a gradient background, it's got to band the background to get, Whereas if that's what you're going to use, then just be careful not to use any gradient colors, either for the background or the model itself, and it'll usually work fine. Since I'm on a 64-bit machine, I tend to use the IYUV codec. It's just one of the ones that's available on. I tend to use it a lot, but remember, whatever you compress it as, whatever you play it on has got to have the same codec. So I'm playing on my own machine, I don't care. Frequently, I mentioned we use Handbrake to go to MP3 or MP4. They use the H.264 codec in there. So that's another way around it. Record it either uncompressed or whatever you want, and then use something else to put it in MP4. Yeah, if I tell it to just record one of these, yeah, I know that. IYUVs, if you have a 64-bit machine, you'll most likely have those codecs pre-installed. Windows will normally install Microsoft Video 1, and if you're on a 32-bit machine, it'll put the Cinepack codec by Radius. You notice Cinepack isn't on here because this is a 64-bit machine. Is yours 32-bit?
No.
Oh, okay.